Alright, chapter 10 is all about circles, so we're just going to start out with some information about things that go on inside of the circle. Remember, if you need to take a little bit more time writing down the vocabulary than I give you, you can always pause it. So, a circle is the locus of all points in a plane equidistant from the given point called the center. So if I have a circle here in our little diagram, if I have the center point, point K, each point out here is actually equidistant from the center point. So that's what makes a circle. The center is the middle of the circle, equidistant from every point on the circle. So if that is 5 centimeters, then this would also be 5 centimeters. The radius is a segment with endpoints that are the center and a point on the line. So a radius is the center and the point on the line. So if that point on the line was point J, I would call our radius KJ. A chord is a segment with both endpoints on the circle. So I might call this point M and point N. So N may be a chord, and there may be multiple chords that you see, but remember the endpoints must be on the circle. A diameter should not be a new term. A diameter is a chord that passes through the center of the circle. So, I might have something like that. So, let's call this Z and Y. Since it passes through the center and the end points are on the circle, I would call this the diameter. Diameter ZY. And you might be thinking, well, how do I name this circle? Well, I'm going to name this circle by the center point. So this is going to be called circle K, or in words, it would be circle K. All right, a couple more things. Concentric circles are just coplanar circles with the same center. So that's an example. Since both circles share this center, then I would call them concentric circles. Circumference is the distance around the circle, very similar to the perimeter that you're used to seeing. And here are our two equations. We can use our circumference equals pi times the diameter, or 2 pi times our radius. And remember, our pi is about 3.14 units. Pi, about 3.14 units, is just an irrational number represented by the ratio of the circumference and the circle to the diameter. So that pi is actually a number. It's not just a variable. Inscribed is a polygon. A polygon is inscribed in a circle if the vertices lie on the circle. So if you notice in this picture, because I have a triangle and my vertices all lie on the circle, I could call this an inscribed triangle. And then the circle in which the polygon is inscribed is called the circumscribed circle. Alright, so that completes our notes for our vocabulary. So we'll get into our first section. Identify segments in a circle. So what we just learned above, we need to name the circle and identify the radius, and we might do a couple more things. So remember, the name is labeled by the center point. So I'm going to call this circle E. Remember, a radius is from the center to the outside. So one might be ED. Notice my center point needs to be included. I could also say EB is also a radius as well, because it goes from the center point to the outside. They didn't ask for this, but a chord. Remember, a chord has endpoints on the circle. Alright, so A is on the circle and so is C, so I could say that AC is a chord. And then my diameter goes through the center, so BD would be my whole diameter. And remember, the diameter also fits into a chord. So every chord isn't a diameter, but every diameter is a chord. All right, let's go to the next page. Need to erase this. All right, so I need to name the chord and the diameter. Well, before we start, we know that our center point is Q, so I could name this circle Q. A chord has endpoints on the exterior of the circle, so I might say WZ. Another endpoint, so W and Y is on the exterior of the circle. I also know that X and Z are on the exterior of the circle. So those three are represented. Now, because these two go through the center, they are chords that are through the center. I could also call them the diameter. Because again, they both go through that center. Alright, a radius goes from the center to the outside, so I could say QY or QX or QW or QZ. Notice that in my radius, I always include my center point. Alright, go ahead and stop this video and try your next two checkpoints. Here are your answers to those two checkpoints. Alright, radius and diameter relationship. So if a circle has a radius and diameter, the following relationships are true. So if you are trying to find your radius, given your diameter, you're going to just take half of your diameter. So your diameter divided by 2. If you are asked to find the diameter, because from your center point to your side of your triangle or your circle is the same distance as anything to the side of your triangle, you know that QV is congruent to VS. So I'm just going to take it times my radius times 2. Alright, let's try some of those. Try those formulas. So I have that RT equals 21 centimeters. And RT would be considered my diameter. What is the length of QV? Well, I know that RT is a diameter, so it is congruent to QS because they're both diameters. So since QS is 21 centimeters also, I'm trying to find my radius, so I would say QV equals half of QS. So half of 21 gives me QV to be 10.5 centimeters. Alright, go ahead and stop your checkpoint and try your checkpoint number 2. And here's your answer for that. Alright, circle pairs. Two circles are congruent if and only if they have congruent radii. So that radii or radius allows me to say that because my radii are congruent, then my circles are congruent, which makes sense. The second thing, all circles are similar. Well, because all of my radii are going to be the same, no matter where it is on the circle, I know that my radii, or my diameter, or whatever I want to compare, are proportional. And last, concentric circles are coplanar, meaning they're in the same plane, that have the same center. So notice circle A has a radius of AB, and the big circle A has a radius of AC. They both share that center point. Alrighty. Find the measures of intersecting circles. So the diameter of circle X is 22 units. So I have a diameter and it's going to be 22 units. The diameter of Y is 16 units. I also know that WZ is 5 units. I need to find XY. Alright, well, because I know both diameters, I also know both radii. So the radius of circle X would equal 11 units, which also tells me that XZ is a radius, so I know that XZ is going to be 11 units. I also know the diameter of circle Y, so I also know the radius of circle Y, which is 8 units, because 16 divided by 2 and 22 divided by 2, so I know that WY is 8 units. Alright, well, if I take WZ, which is 11, but I put, or XZ, I'm sorry, XZ, I'm taking this part out. I also have point W, and I know that this is 5. So, because I know this is 11, I know that 11 minus 5 gives me 6, so 6 would also be here. And then if I took away WY, because I have point Z in there, I know that this whole thing is 8, and WZ again is 5. So I can also say that 8 minus 5 gives me 3, which 3 goes here. So I know that XY is made up of, what do we have? What did we just find? We know that XW is 6. We know that WZ is 5. And then we know that ZY is 3. So I know that XY equals 6 plus 5 plus 3, which would equal 14 units. Alright, try your next checkpoint real quick. Go ahead and try that. And there is your answer. We're going to stop this video so we can work on circumference in the next video that won't take too long. So go ahead and join us for part 2.